Hello everyone, I'm Sahana. I'm here to present the topic that is test of significance of attributes and test for difference between proportion of success illustration. Introduction on test of significance for attributes. A test of significance is a formal procedure for comparing observed data with a claim or hypothesis, the truth of which is being assessed. The results of a significance test are expressed in terms of a probability that measures how well the data and the claim agree, as distinguished from variable where quantitative measurements of a phenomenon is possible in case of attributes. We can only find out the presence or absence of particular characteristics. The sampling of attributes may therefore be regarded as the drawing of samples from a population whose members possesses the attribute A or not A. The test of significance normally means you're comparing the observed data with the hypothesis or the claim, okay, where you assess the truth. Next, it is the in case of attributes in the sense a quality or feature regarding a characteristic or inherent part of someone or something. This mainly says about the quality variables, and there you compare. Okay, the sampling of attributes may therefore be regarded as the drawing of samples from population whose members possess the attribute A or not B. The sample might be A or it might be B. A or not A. Okay. If a sample may be taken as, here we'll take two samples, okay, people classified as literates and illiterates. We are seeing two samples here, that is people are classified as literates and illiterates. Such data, the binomial type of problems may be formed. Binomial in the sense two, so here two samples are seen. The selection of an individual on sampling may be called as event. Event is here, for example, here you have taken literates and illiterates, right? So when you're looking about illiterates, when we are looking upon illiterates, so that is one individual, right? That is event, one event. You're selecting one event. Next, the appearance of an attributes A may be taken as successes and its non-appearance as failure. In a sense, first you take a null hypothesis, or you're taking one attribute as success and its alternative might be the failure. If 1,000 people selected for sample, you're selecting 1,000 people for sample where 100 are found literates and 900 are illiterates, right? 1,000 out of 1,000 sample, the 100 are literates and rest 900 are illiterates. We can say that the sample consists of 100 units of success and 900 of failure. So let's write in the probability manner. The probability of success is P is equal to 100, that is literates divided by the size of the sample, that will come up to 0.1. Next, the probability of failure is Q is equal to 900 divided by 1,000. 1,000 is a size, or that the answer will be 0.9. That is P plus Q is equal to 0.1 plus 0.9 is equal to 1. A significance test starts with a careful statement of the claims being compared. The claim tested by statistical test is called the null hypothesis, that is denoted by H0. The test is designed to assess the strength of a variance against the null hypothesis. Often the null hypothesis is a statement of no difference. Initially, we assume the null hypothesis. Later, alternative hypothesis is assumed, that is denoted by HA. The various tests of significance for attributes are discussed under the following heads. Here, the various tests of significance of attributes are seen. First one is test for number of successors. Second one, test for proportion of successors. And third one, test for difference between proportions. Let's move on to first one, test for number of successors. The sampling distribution of the number of successors follows a binomial probability distribution. Hence, a standard error is given by the formula. Standard error of number of successors is equal to square root of NPQ, where N is equal to size of the sample, P is equal to probability of success in each trial, Q is equal to 1 minus P, that is probability of failure. Under test for number of successors, here binomial probability distribution is considered. As we all know, binomial is 2, that is 2 samples are seen at a time and we compare which is okay or which is not okay. The standard error of number of successes can be measured as square root of NPQ, where N stands for size of the sample, P is the probability of success in each trial, Q will be the probability of failure, and it is measured by 1 minus P. Next, test for proportion of successors. Instead of recording the number of success in each sample, we might record the proportion of success, that is 1 divided by nth of the number of successes in each sample, as this would amount to dividing all figures of the record by n. The mean proportion of successors by P. The standard deviation of the proportion successes would be square root of PQ divided by N. Here we don't measure the number of success. Here the proportion of success is seen in this sample. Here N is a size of the under proportion of successors. Here we see the proportion of successes rather than number of successes. Then 1.nth of the number of successes in each sample will be considered. The standard deviation formula would be the square root of PQ divided by N, where N stands for the total size of the sample. Next, Z symbolizes the critical value. Here, at 5% level of significance, the tabulated value was 1.96, and under 1% level of significance, the tabulated value would be 2.58. Next, test for difference between proportion. This is a third type. If two samples are drawn from different population, we may be interested in finding out whether the difference between the proportion of successors is significant or not. In such a case, we take the hypothesis that the difference between P1, that is the proportion of success in one sample, and P2, that is proportion of successes in the another sample, is due to fluctuation of random sample. The standard error of the difference between proportions is calculated by applying the formula. So here two samples will be there. So in that two samples we are naming it as P1 for the proportion of success of first sample and P2 for the proportion of successes for the second sample. And the standard error of the difference between proportion would be calculated as standard error, that is P1 minus P2, is equal to square root of PQ into 1 divided by N1 plus 1 divided by N2, where P is equal to the pooled estimate for the actual proportion in the population, that is nothing but probability of success. 1 minus P, that is Q, is equal to probability of failure. P1 is equal to probability of success in sample A. P2 is equal to probability of success in sample B. N1 is equal to sample size of population A. N2 is equal to sample size of population B. The value of P is obtained as follows. P is equal to N1 into P1 plus N2 into P2 divided by N1 plus N2. If P1 minus P2 is less than 1.96 standard error, that is 5% level of significance, the difference is regarded. Z is equal to P1 minus P2 divided by square root of P into 1 minus P into 1 divided by N1 plus 1 divided by N2. Test for difference between proportion of success illustration. This is the second part of my seminar. Let us see the sum. In a random sample of 900 persons from Mumbai, 400 are found to be consumers of rice. In another random sample from Chennai, 500 out of 1100 are found to be consumers of rice. Do these data reveal significant difference between these cities so far as the proportion of rice consumers at 1% level of significance? The question says that in the first city, that is Mumbai, it is 900 sample, size of sample. There 400 are found to be the consumers. Whereas in Chennai, it is 1100 is a sample and 500 are the consumers. Here we have to test this level of significance under 1% level. Let's see the solution. Let us assume null hypothesis to be not significant. H0 is equal to P1 is equal to P2. There is no significance difference between the rice consumers of two cities. H1, that is alternative hypothesis. P1 is not equal to P2. There is significant difference between the rice consumers of two cities. Here given in the question is N1, that is first sample size is 900, N2 the second sample size was 1100, P1 the consumers, the total consumer number was 400. So 400 divided by the sample of the first sample, that is 400 divided by 900, that is 0.4. Next P2, same like that only, that is 500 the consumers divided by the sample size is 1100 is equal to 0.45. Next P is equal to N1 into P1 plus N2 into P2 divided by N1 plus N2. Here N1 is equal to 900 into P1 is 0.4 plus N2 is 1100 into P2 is 0.45 divided by N1 is 900 plus N2 is 1100. 900 into 0.4 will come up to 360 plus 1100 into 0.45 will come up to 495 divided by 900 plus 1100 will come up to 2000. 360 plus 495 is 855 divided by 2000. So total P value will be 0.43. Q is equal to 1 minus P, that is equal to 1 minus, we found out the value of P, that is 0.43, that is equal to 0.57. Z is equal to P1 minus P2 divided by square root of P into 1 minus P into 1 divided by N1 plus 1 divided. P1 is 0.4 minus P2 is 0.45 divided by square root of P, that is 0.43 into 1 minus P will be 0.57 into 1 divided by N1, that is 1 divided by 900 plus 1 divided by N2, that is 1 divided by 1100. 0.4 minus 0.45 is equal to minus 0.05 divided by square root of 0.43 into 0.57 will be 0.2451. Here 1 divided by 900 will come up to 0.001 plus 1 divided by 1100 will come up to 0.0009. Next, minus 0.05 divided by square root of 0.2451 into 0.001 plus 0.0009 will come up to 0.0019. Next, minus 0.05 divided by square root of product of 0.2451 into 0.00919 will come up to 0.000466. Minus 0.05 divided by square root of 0.000466 will come up to 0.022. So Z value is minus 2.27. At the 1% level of significance, Z value should fall between 2.58 to minus 2.58. In the above calculation, Z value is minus 2.27. This value falls within the tabulated Z value. Hence, the null hypothesis is accepted and there is no significant difference between the rice consumers of two cities. Since 1% level of significance, the tabulated value is 2.58 and it should fall, the Z value should fall between 2.58 to minus 2.58. Our Z value is come up to minus 2.27, so this falls within the value. So here the null hypothesis is accepted and there is no significant difference between both the cities. As a concluding part, I would like to say that a test of significance, hence being proved to be a formal procedural process of comparing observed data with hypothesis, is become one of the important statistical method. The claim is a statement about P or the population mean. By following specific steps, the testing of significance. This is one of the important topic under business research and helps one to know the basic statistical calculation. Hence, proved test of significance is some process with comparing of observed data with the hypothesis and using of the statistical method. Thank you.